Hello, my dear students in grade 9. I hope you are all good. And also, I hope to see you soon in class with us. During the previous week in school, I was discussing and working with your friends in our lesson that we have seen last year with some additional information. This lesson was about the square roots. What did we cover in class last week? First, of course, we defined square roots. Number two, we found square roots of some perfect squares. Then we learned how to find perfect square roots of non-perfect squares. We performed calculations with square roots, addition, subtraction, multiplication, and division. Then we expanded and reduced an expression with the square roots. We compared two square roots. And finally, we rationalized the denominator of a fraction having square roots in the denominator. As a definition of square roots, it is radical A. So the square root is written as radical A. Always it is radical A squared. So the inside of the square of the radical, this is called the radical symbol. So inside we have a square. Why? Because we always simplify the square with the radical and it goes outside. Its root is A. So the root of radical A squared is A. The root of radical A all of it squared is also A since the square cancels the radical, and radical minus A, all of it squared is equal to A. This is not considered as negative. Why? Since it's a negative base and the exponent is even, so it becomes positive. So inside we have a positive square root. And we simplified some square roots, as you can see from the examples down. We solved many examples like these. You can practice them. Always the square root of 0 is 0. The square root of 1 is 1. A negative radicand does not exist. So if you have a negative inside the radical in this form, it doesn't exist. For example, radical negative 5, radical negative 9, all these doesn't exist. But if the negative is outside, it doesn't have to do with the radical inside, it stays outside. Now, how can we find the square root of some perfect squared? You know that the perfect squared are the number that can be written as a square of another number. So 1 square is the perfect square of 1, 2 square is the perfect square of 4, 3 square is 9, 4 square is 16, etc. So those are called perfect squares. And don't forget that radical A squared is equal to A. For example, if I have radical 36, I ask, can I write 36 as a perfect squared? Yes. How do we write it? It's written 6 squared. So it is radical 6 squared, then the squared cancels the radical and the answer is 6. In this way, we find the square roots of perfect squares. Then how can we find the square roots of non-perfect squares? Suppose that inside the radical, I have a number that cannot be written as a perfect square. What should I do? I should decompose the given number inside the radical into product of prime factors using prime factorization. For example, 18 cannot be written as a perfect squared, so I make the prime factorization of 18. The prime factors of 18 are 2 times the 3 square. Then I replace these prime factors inside the radical, so I have radical 2 times the 3 squared. What comes outside? Of course, 2 cannot come outside because it doesn't have a square. So 3 squared, it comes outside as a 3. So my answer will be 3 radical 2. This is the simplified radical 18. You have another solved example, which is radical 24. You can see the solution. Now, these are also additional exercises for you to solve and to practice more. Okay, now how can we perform calculations with the square roots? First, I will start with addition and subtraction. It's very important for you to know that we can only add or subtract radicals with the same radicand. So if the number inside is the same of the radical, then we can add or subtract who? We can add or subtract the coefficient of the radicand. I will give you one example. For example, 5 radical 2 plus 6 radical 2. Since we have a plus and both radicals has 2 inside, then these are similar. Then we say 5 plus 6 is 11, and we keep the radical 2 as it is. You have also solved exercises for you. Now, if you have, for example, 6 radical 2 plus 8 radical 5, here the radicands are different. So since we have different radicands, so the answer stays as it is. Okay? Now, this is another example. If we have to add this expression, I look inside the radical. Here I have radical 8, here I have radical 18, here I have radical 32. Are they similar? No, but we can simplify the radicands inside. So to simplify 8, I make the prime factorization of 8, I make the prime factorization of 18, then I do the prime factorization of 32. Now I replace the prime factors inside the radicals, then I simplify each radical until they become like radicals, then I can add or subtract these radicals. How can we do the multiplication? In multiplication, as I said last year, we have 3 rules to multiply. Either I'm multiplying a number with a radical, a times radical b is a radical b. For example, 3 times radical 7 is a 3 radical 7. Radical a times radical b, if I'm multiplying 2 radicals with different radicands inside, it will give me radical a times b. For example, radical 3 times radical 7 is radical 3 times 7 is 21. Now radical a times radical a, I'm multiplying 2 radicals with the same radicand. It will give me radical a all of it squared, and the square cancels the radical, it gives you a. For example, radical a 3 times radical 3, it's radical 3 all of it squared, then the answer is 3. Now division, we can if we have a fraction with a radical in numerator and denominator, we can write them in the same radical, then we can simplify the fraction. Or if it is a fraction in the same radical, we can split both the numerator and denominator in order to simplify. And of course, you have solved examples for you. Now, if we have radical a times b, we can split the radical. So we can write radical a times radical b. Also, we can do this in division. But this cannot be done in addition and subtraction. So inside the radical, if we have a plus or a minus, we do the calculation inside, but we cannot split the radical. Now, how can we expand or reduce an expression? To expand or reduce is to get rid of parentheses in the expression. How can we do this? We have rules of multiplication that we studied also last year. You should memorize these rules. If I'm multiplying a parenthesis by something before it, then we multiply the first by the first, then the first by the second. Here, if I'm multiplying 2 parentheses together, I multiply the first by the first, then the first by the second, the second by the first, then the second by the second. Of course, here we have applied exercises for you. You can apply these exercises on draft to practice more. Also, we can expand or reduce an expression using remarkable identities. The 3 remarkable identities that we also studied last year, a plus b all of it squared. We should memorize how we write these remarkable identities. A squared plus 2ab plus b squared. A minus b all of it squared is a squared minus 2ab plus b squared. A minus b into a plus b. If I'm multiplying 2 parentheses with the same terms inside, 1 minus 1 plus, it's a squared minus b squared. These are the remarkable identities. How can we compare 2 square roots? To compare 2 square roots or a square root with a number, we make them both square. So radical a is compared with radical b, we make it radical a all of it squared compared to radical b all of it squared. Then we compare the answers and we compare the radicals. After that, if you have inside the radical a binomial, suppose you do not have a number, you have a binomial. For example, radical 5 plus a 3 inside the big radical. We cannot get the binomial outside simply by saying the squared cancels the radical. No, we should compare a with b. If a is greater than b, in the case of addition, we add directly. So it comes out as a plus b. But in case of subtraction, we should compare a with b. A should be greater than b to say the square cancels the radical. So if A is greater than B, directly the square cancels the radical and you get it outside. But if A is less than B, we should change the places. So after we compare, we should say that we change the places, then 4 is, it comes out as radical 11 minus 4. How can we rationalize the denominator of a fraction? To rationalize the denominator of a fraction is to get rid of the radical in the denominator. How we do this? We multiply the fraction by the conjugate of the denominator. If in your denominator you have radical A, its conjugate is radical A. So we multiply by a fraction having radical A over radical A. If in the denominator you have A radical B, then the conjugate will be radical B over radical B. Now, if you have an operation with the radical in the denominator, the conjugate will be the same denominator, but with a different sign. So the conjugate of radical A plus B is radical A minus B. So we multiply by a fraction having radical A minus B. And if you have radical A minus B, the conjugate will be a fraction radical A plus B over radical A plus B. Also, I solved this exercise for you. You can practice how we do it, the rationalize. Here you have 3 exercises about rationalizing a fraction solved for you. This was the lecture that we finished last week, and we are still working exercises in class. And every day on WhatsApp, I'm sending you all the exercises we are performing in class. Please, if you have any question, don't hesitate to contact me and I will make things easier for you. Thank you.